Today, the mystery of the red planet will be revealed to all of humanity. We will reveal to you a Mars you have never known. We have a rare chance to study the case of another planet's death from hydraulic impact before it can happen on our own planet. After what you see, you won't be able to say you didn't know about this. The truth about Mars must be known by everyone so that Earth won't repeat the fate of its red brother. Mars and Earth were formed as planets around the same time, 4.6 billion years ago. They had many similarities: a functioning inner core, a strong magnetic field, a dense atmosphere with oxygen, oceans, and plant life. Today, you will discover irrefutable evidence of this based on scientific research. It is widely believed that Mars died 3.5 billion years ago for unknown reasons, and it has been dead for all of those billions of years just as we know it now. Planetary scientists are puzzled by the mystery of where most of the planet's water and atmosphere reserves have gone, what has happened to the magnetic field, and under what circumstances Mars died. However, the truth is that Mars and Earth had a similar life journey as planets, and only recently Mars has fallen behind. The planet died in a cycle of cataclysms, which the entire solar system goes through every 12,000 years. The planet, which existed for billions of years, full of life, perished in a matter of minutes. And this happened quite recently, and our distant ancestors saw Mars burning with their own eyes. Get ready to hear facts about Mars you never knew. Atmosphere of Mars. Currently, Mars has a very thin, dry, and sparse atmosphere, which is 61 times less dense than Earth's. In terms of composition, Mars's atmosphere is now 96% carbon dioxide, with the remaining percentages being argon and nitrogen, and hundredths fractions of a percent is oxygen and water. However, it wasn't always like this. In October 2022, scientists from the University of Arizona published an article in which they proved, based on the analysis of the hydrogen isotopic composition, that for millions of years, the atmosphere of Mars was humid and had a density comparable to that of Earth's atmosphere today. According to official theory, Mars lost its dense atmosphere 3.5 billion years ago. However, the following facts contradict this theory. While studying meteorites found on Mars, researchers noted that some of them fell to the surface through a dense atmosphere. This became clear after studying the trajectory of the fall of these meteorites. Scientists were also surprised by the fact that the meteorites were shiny and looked like they had recently fallen. After all, usually iron rusts very quickly in the presence of water. If, according to scientists, Mars lost its dense atmosphere 3 billion years ago, then isn't it surprising that those iron meteorites show little or no signs of corrosion and are not covered with sediments? This suggests that Mars lost its dense atmosphere only recently. But researchers were afraid to draw such a conclusion. Scientists wonder what the composition of Mars' atmosphere was in the past, as now it consists almost entirely of carbon dioxide. Researchers from Oxford University have come to the conclusion that Mars once had an oxygen atmosphere similar to that on Earth. They made this discovery based on a study of the oxidation of minerals on Mars. Professor Portnov, PhD in geology and mineralogy, has come to the same conclusion. The color of Mars rocks, red, just like human blood, indicates that its atmosphere was once dense and rich in oxygen. The similarity between the color of the planet and human blood is explained by the same reason: the abundance of iron oxide. Red soil is formed as a result of the weathering of rocks, that is, their chemical and physical destruction. These types of soils are also quite common on Earth and are called red weathering crusts. They're formed under conditions of a warm climate, abundance of water, and free atmospheric oxygen due to the oxidation of iron in the rocks. The red rock of Mars was formed under conditions similar to those on Earth. Mars is red because nearly half of the Martian surface consists of rusty soil. Such rust, an oxide film on the planet's surface, is the rarest phenomenon in the solar system. It exists solely on Earth and on Mars. On other planets and numerous large satellites of planets that have water, rocks remain unchanged for virtually billions of years. For instance, the basalts of the Moon are not oxidized and have a gray color because there has never been an oxygen atmosphere. Earth's red weathering crusts originated a long time ago, but only after free oxygen appeared in the atmosphere. It was produced by blue-green algae in the oceans. All the oxygen in Earth's atmosphere, 1,200 trillion tons, is produced by green plants in just 3,700 years. But if Earth's vegetation were to die out, free oxygen in the atmosphere would disappear very quickly. Could that be what happened on Mars? Currently, only 0.1% of Mars' atmosphere is oxygen, but there was a lot of it not so long ago. According to Professor Pertnov's calculations, in order for the entire surface of Mars to turn red, the planet's rock would have had to consume 5,000 trillion tons of free oxygen during the weathering process. The amount of free oxygen needed to oxidize the rock of Mars could only have been produced by plant life through photosynthesis. This means that there was definitely life on Mars. You will learn more about other evidence of this later. Another mysterious and unexplained fact is that in some places the red color of Mars is just a thin layer on the surface. Mars rovers have drilled the surface of Martian rocks of various compositions many times, and in the pictures you can see for yourself that inside the rocks turned out to be gray, not red. Isn't that surprising that the red color is just a thin layer on the surface of the gray soil, as if it formed yesterday and over a very short period of time? The surface of Mars could oxidize so quickly and extensively only in the event of a very powerful explosion that engulfed the entire planet. What could cause an explosion of such power? Stay tuned for the answer. Magnetic field of Mars. As we can see from the most obvious facts, Mars had a dense oxygen atmosphere and a hot, humid climate. So why is the atmosphere of Mars so sparse now? NASA blames it on the disappearance of the magnetic field. What proves that Mars previously had a strong magnetic field is the fact that minerals in the Martian crust have patches of strong residual magnetization. However, this magnetization of minerals does not provide protection for the whole planet. By the way, for the same reason, humans will not be able to live on Mars, because life on the planet requires not only protection from cosmic radiation, but also a magnetic field of a certain strength. It is interesting that despite the absence of a global magnetic field on Mars, a giant aurora borealis was reported there in April 2022, which was unlike any previously observed. The appearance of such an aurora might indicate a local change in Mars's magnetic field right now. Isn't it surprising that this is happening now in sync with the anomalous polar auroras on Earth? On Earth, changes in the magnetic field in our days occur due to changes in the core. On Mars, it is happening for the same reasons. There is another mystery about the magnetic field of Mars that NASA scientists cannot unravel. According to their hypotheses, 4 billion years ago, due to changes in the core, Mars' strong magnetic field disappeared, and the atmosphere gradually began to be blown away by the solar wind. But Venus does not have a global magnetic field either, yet its dense atmosphere hasn't been blown away by the solar wind. Despite having different densities, both the atmospheres of Mars and Venus are composed of 96% carbon dioxide. There are suggestions that the atmosphere of Venus is preserved by the ionosphere and the induced or secondary magnetic field. However, the same conditions exist on Mars, but there is no dense atmosphere. Robin Ramstad from the Swedish Institute of Space Physics proved in his research that even now the weak and sparse atmosphere of Mars cannot be blown away by the solar wind due to the protection from the induced magnetic field, as is the case on Venus. How is it possible that Venus's atmosphere remained despite the absence of a strong magnetic field, while on Mars it did not? The atmosphere on Mars is likely to have disappeared not due to the solar wind and not over 4 billion years, as NASA tells us, but under completely different circumstances. Then what happened on Mars? What was the scale of the catastrophe to deprive Mars of a dense oxygen atmosphere? You will find out more about this later. Rivers and lakes on Mars. Currently, Mars is a dry and cold planet with virtually no liquid water. All water found on Mars is in the form of water ice under layers of soil or on polar caps. During Martian spring and summer, seasonal streams of liquid water consisting of thawed salt solutions can be observed. However, in the past, the hydrosphere of Mars was abundant in liquid water that flowed in a warm and humid climate. This is evidenced by numerous well-preserved riverbeds and lake deposits. Indeed, the presence of rivers with liquid water in Mars's past suggests that once its atmosphere must have been much denser and warmer. As evidence of river processes, rovers on Mars have discovered deposits of clay, river gravel, and sandstone with textures of wavy ripple marks that are formed in exactly the same conditions on Earth. By the way, the rhythmic layering of lake sediments suggests that Mars once had a large moon, not like its current moons Phobos and Deimos. Only in the presence of a large moon can tides and ebbs occur, which give a rhythmic alteration of layers on the shores of water bodies. Lakes on Mars were formed in the depressions of the relief in lowlands or, for example, in impact craters, just like many lakes on Earth. Interestingly, lake breaches and floods often occurred on Mars, just as they do now on Earth due to heavy rainfall and river floods during global catastrophes. Take a look at these ancient rivers and lakes of Mars in satellite images. Notice how Martian rivers resemble modern river systems on Earth. One of the longest, now dried-up river systems on Mars was nearly 700 kilometers long, which is roughly half the length of the Colorado River on Earth. And this river, Rule Vallis, left a channel which is 1,500 kilometers long, 7 kilometers wide, and 300 meters deep. Moreover, in 2019, a study by scientists from the University of Chicago analyzed 200 dry rivers on Mars. It was found that in hundreds of areas on Mars, the rivers were wider and deeper than on Earth, and they had existed on the red planet for an incredibly long period of 1 billion years. This makes their disappearance even more mysterious and inexplicable for planetary scientists. Look at the map showing the enormous number of dry lakes and river systems that have been discovered on the surface of Mars during modern explorations. This tells us, first of all, that there used to be abundant rainfalls on Mars, which filled the rivers and lakes with water. This is only possible with a continuous circulation of water in nature, which implies the presence of an ocean. Scientists believe that all these rivers and lakes dried up on Mars 3.5 billion years ago. But is that really so? Don't you find it strange that we can still see such clear outlines and banks of these channels? Over billions of years, weathering processes should have eroded and buried these supposedly ancient canyons and channels. After all, we can see the ancient craters on Mars is eroded, but for some reason the riverbeds haven't suffered from erosion at all. All of this suggests that these rivers were flowing on the surface of Mars quite recently. Mars's ocean. Despite ongoing scientific debates about whether there was a large body of water on the northern plains of Mars, thousands of experts find convincing evidence for the existence of an ocean on Mars. And the simplest and most obvious evidence of the presence of an ocean on Mars is its current landscape. Take a look at a topographical map of Mars. The blue color on the map indicates lowlands, while the red indicates highlands. Some scientists still assume that these blue lowlands on Mars are just a few impacts from large meteorites. Now, take a look at a topographical map of Earth made in the same colors. all of the lowered areas of the Earth's landscape have become the oceans we see today. Can you see the similarities between the blue areas of these two maps? In case you have a question of why there was only one ocean and one continent on Mars, there is a simple answer. 300 million years ago, there was only one continent on Earth too, for example, Pangaea, and this had happened on Earth several times. Curiously, the total area of all Earth's continents is approximately equal to the total surface area of Mars. If Mars were to get any bigger, it would resemble Earth like two peas in a pod. Let's get back to the question of the ocean on Mars. The planet's surface is divided into two parts. The first part is the southern high-standing continent, heavily littered with meteorite craters. The second part is the vast northern lowlands called the Vastitas Borealis Formation. The surface of lowlands is practically untouched by meteorites, as if it were protected from impacts. Interestingly, the boundary separating the continent and the lowland runs at the same height, approximately minus 3,900 meters. On Earth, such a line represents the zero level of the world's oceans. Relying on the topography of the landscape, in 1989, the American geologist T. Parker and his colleagues were the first to come to the simple and obvious conclusion that there was an ocean on Mars. Parker and his co-authors put forward a bold hypothesis. The boundary of the Vastitas Formation is a shoreline, and the formation itself is the bottom sediments of the ocean that once filled up the northern lowlands of Mars. The coastline on Mars is just as varied as on Earth. Some places it is a gentle ledge, some other places it is high bluffs and cliffs. However, this evidence was not enough for skeptics. Well, let's see what other facts point to the presence of an ocean on the northern plains of Vastitas. We have already established that thousands of rivers existed on Mars, and they must have flowed down towards the Martian Ocean, just like on Earth. On Earth, rivers carry not only their waters to the ocean, but also various sedimentary materials, such as pebbles, sand, and clay. When rivers meet a sea or an ocean, they form deltas of various shapes, both on land and underwater. For example, Indus, Ganges, Amazon, Mississippi, Nile, Volga, Lena, and many other rivers on Earth form deltas. Surprisingly, but extensive deltas have also been preserved on Mars to this day. Researchers have discovered on the Red Planet more than 6,500 kilometers of dried-up river deltas or belts of underwater channels flowing into the Martian Ocean. These deltas have left numerous sedimentary deposits on the oceanic coast, at least 900 meters thick. These sediments cover hundreds of thousands of square kilometers along the shores of the former ocean. In February 2021, the Perseverance rover discovered a fan-shaped delta with traces of flash flooding at Jezero crater. At the late stage of the river's life, torrents of water carried boulders weighing several tons for tens of kilometers at tremendous speed. Researchers cannot say what caused such cataclysms in the river. Traces of catastrophic floods have also been found on Mars in the vicinity of the Valles Marineris region. These are giant channels of outflowing water that have no tributaries and start as full-scale channels. These channels are assumed to have been formed by a sudden catastrophic water discharge at a rate of 100 cubic meters per hour. Nothing like this has ever happened on Earth. Researchers say these were some catastrophic events. The next interesting fact indicating the presence of an ocean on the northern plains of Mars is the shape of impact craters from meteorite impacts. The fact is that when meteorites fall into moist soil, they leave a trace of splashing liquid mud around them. In the pictures on the left, you can see a crater from a meteorite impact on dry soil, in the center on moist soil, and on the right on the soil heavily saturated with water. Interestingly, as you move away from the shoreline on the northern plains, the proportion of craters with liquid mud around them increases. This indicates a high residual water content in the soils in the place of the former ocean. On this map, you can see such craters marked in orange. The presence of an ocean on the northern ozone planes in the past is also confirmed by a NASA study based on analysis of hydrogen and deuterium isotopes. According to the analysis, the volume of water on the planet was 6.5 times larger than what remains in the polar ice caps of Mars today. This volume of water was greater than what the Arctic Ocean on Earth contains. However, for some reason, Mars lost 87% of its water. Interestingly, if the Martian ocean had evaporated gradually, researchers would have seen a gradual change in the level of delta deposits and how shallow water sediments replaced deep water ones. On Earth, geologists are well aware of the sequence of sediments formed by a sea receding from the shore for millions of years. However, nothing similar is observed on Mars. On the contrary, there are traces of catastrophic outflows of water, indicating that the ocean has disappeared instantaneously. How is it possible? What was that monstrous catastrophe? Keep this conclusion in mind. We will come back to it later. Life on Mars. As you remember, the oxygen atmosphere on Earth appeared only thanks to the appearance of life on the planet, namely blue-green photosynthetic algae in the ocean. It would be logical to assume that since Mars had an oxygen atmosphere, then it must have been created by plant life, just like on Earth. You must have often heard about the search for life on Mars, but unfortunately, you are unlikely to know that life on Mars has already been found many times. The history of discovering life on Mars begins in 1996, when a group of scientists published an article about finding bacteria-like microscopic fossils in one of the Martian meteorites that was found in Antarctica. Later, the scientists changed their minds and declared that those were just rock formations. Surprisingly, the discovery of a large number of organic molecules found in samples of the Jezero crater by the Perseverance rover in 2022 did not cause much excitement, despite the fact that NASA officially announced it. It turned out that back in 2013, the Curiosity rover found signs of organic matter in rock samples, but this was not recognized as an official discovery of life on Mars either. Think about it. If there was a living ocean on Mars, what else besides bacteria could have appeared in the ocean waters? What kind of marine organisms develop in the warm ocean waters on Earth? You'll be shocked to learn what the rovers actually found, but what NASA scientists forgot to mention. For 7 years, starting in 2012, the Curiosity rover has been plowing through Gale crater, which is located on the coast of the dried-up Martian Ocean. Scientists believe that 3.5 billion years ago, Gale crater was a lake or a body of water. Similar lakes on the seashore on Earth are often filled with salt water due to the proximity of the ocean and are called lagoons. Interestingly, salt-saturated rocks have also been found in Gale crater. The Journal of Astrobiology and Space Science Reviews published a collaborative study of 15 different institutes and science centers in 2020, which provided comprehensive evidence for geologists and paleontologists of fossilized organisms found in Gale crater on Mars. Based on an examination of 3,000 photographs, there were detected and identified specimens resembling terrestrial algae, lichens, microbial mats, stromatolites, and many others. These were exactly the same organisms that now live on Earth. We will provide just a few examples. Those very microorganisms, blue-green algae or cyanobacteria, responsible for Earth's oxygen atmosphere, create structures called stromatolites. Modern stromatolites can be seen on the coast of Western Australia. Take a look at these oval towers built by the current living marine stromatolites in Lake Thetis, Australia, Earth. No geological processes can create such forms, unlike living organisms. And now, look at the exact same structures on Mars. These are Martian stromatolites. Now, take a look at the official NASA images, which show branching filaments of cyanobacteria found in the same region on Mars. Didn't these objects deserve a more detailed study by the scientists who operated the rover? Now, look at the following pictures. These are the fruiting bodies of algae found right there on Mars. And now look at these bizarre forms of Martian plants. Their analogs now live on Earth. You might say, I'm not an algae expert, I know nothing about algae, and I can't tell if these findings are fossilized organisms or just bizarre rocks. However, the authors of this research, 10 of whom are well-known experts on algae, unequivocally identified these specimens as plants. Now, take a look at this photo. You might think this is Earth, but it's still a picture taken by Curiosity in Gale Crater. These are real corals on Mars. They have been frozen in time as if they were alive just yesterday. The same kind of corals can be found today on the Great Barrier Reef in Australia. Note the wavy texture of the sea ripples on the surface of the bottom of the Martian image. It looks exactly like the sand on the seashore after a low tide on Earth. This is stunning evidence of life on Mars. But the most shocking thing to experts about this discovery is how well preserved it is, despite its fragility. These corals have not eroded in any way, as if they were laying at the bottom of a Martian lagoon just yesterday. Doesn't this discovery deserve extensive media coverage? Of course, life on Mars existed not only in Gale Crater. There was also amazing evidence of life found in other regions of the planet that NASA and the media forgot to tell us about. Amazing convex formations branching like tree branches were photographed from satellites in the basin of Antoniadi crater, which is also located near the former Martian Ocean. Italian scientist Fabio Vittorio de Blasio published an article in 2022 detailing all possible formation mechanisms of such an unusual structure. These could not be rivers or deltas, and the only reasonable explanation was that these were reefs formed by microbial communities. Just think about it. These are entire reef systems visible from satellite images of Mars. Look how similar they are to Earth's modern reef systems. It is important to note that according to satellite studies, carbonate rock composition was found in the same region, and this type of composition is characteristic of reef structures. Yet another unusual sign of Martian life was discovered by the Perseverance rover in 2021. Look at these rocks with holes from Earth. Such holes are made by rock-boring bivalves that drill shelters for themselves. Now, take a look at these numerous rocks captured by the Mars rover in Jezero crater on the shore of the Martian Ocean. According to the authors of the study, these holes in the rocks were also drilled by bivalve mollusks. Some might argue that those could be dozens of meteorites laying in one place, but meteorites tend to have a metallic luster. It cannot be said that these rocks look like porous Martian basalts either, because basalts have a dark color. However, for some reason, the rover did not see anything interesting in these exotic porous rocks and just drove past them. Now, you have seen only a small part of the findings of recent life on Mars, which were discovered by researchers seeking the truth. They are fully consistent with what scientists would expect to find on Mars. There are still a lot of findings left out of the picture. When we first saw this information, we were shocked. Why is NASA silent about this? Why haven't the discoveries of a decade ago been thoroughly studied yet? If it is denied that these are traces of paleontological findings of plants and microorganisms, why have no official refutations been made? How can it be that after almost 50 years of research missions on the surface of Mars, the signs of life have never been officially established despite the huge volume of obvious facts that complement each other? What has been done in 50 years? Billions of dollars have been spent, and what have we learned so far? Information about fossil finds on Mars is deliberately hidden. If we assume that all these findings are traces of active Martian life, then it turns out that Mars passed the same path of evolutionary development as Earth. The observed species have a similar origin and have their analogs among modern inhabitants of Earth. which means that Mars could not have perished 3.5 billion years ago. Otherwise, these species would not have had time to evolve. The fact that the extinction of Martian species occurred very recently is also evidenced by the excellent preservation of the findings, which completely contradicts the accepted dating of the demise of Mars. And to discourage inquisitive people from studying this topic, NASA adopted a tactic of posting on the internet hundreds of thousands of identical, boring photos from rovers in which there is nothing interesting. This is done to disappoint anyone who still had any interest in studying life on Mars and to make them give up hope. Meanwhile, the truth is right in front of everyone. Catastrophic eruptions on Mars. Current magmatic and volcanic activity on Mars is also puzzling researchers, as these processes cannot occur on a planet that has been dead for billions of years. Prior to recent discoveries, most planetary scientists thought Mars was geologically dead. Take a look at this region of Mars. It's called the Tharsis Plateau or Tarshish. This region is a massive volcanic plateau which was formed as a result of the magma ascent from a giant plume. The volcanic rocks of the Tharsis Plateau are not magnetized, which indicates that Mars' magnetic field was absent during these eruptions. The 5 largest volcanoes in the solar system are located on the Tharsis volcanic plateau and are considered to be extinct. According to the official theory, these volcanoes last erupted 150 million years ago and have not been active since then. However, on September 17, 2018, a 900-kilometer-long cloud was observed, ejected by Arsia Mons, one of the volcanoes in the region. This suggests that these volcanoes of Mars are not dead. Also, in this part of Mars, there is a giant 11-kilometer deep Valles Marineris, where the giant channels of catastrophic water discharge originated. Theoretical calculations suggest that this valley formed as a result of the uplift of the terrain caused by a magma chamber. The uplift experienced stretching during inflation and broke along the crack, which is what the Mariner Valley represents. At the end of the Mariner Valley, there is a region called the Labyrinth of Night, which is completely flooded with relatively young lava. It appears as if an incredibly powerful, catastrophic explosion occurred in this area. Nothing like this has ever happened on Earth, at least not yet. We'll talk about when and what happened here in just a few minutes. There are large volcanoes on Mars, not only on the Tharsis Plateau, but also on the opposite side of the hemisphere, in the region of Elysium Planitia. In 2018, NASA's InSight Mars lander started to receive information about thousands of Marsquakes in this region, near a fault called the Cerberus fossae. And on May 4, 2022, a Marsquake of magnitude 5 was recorded in this region of Mars, the strongest ever observed on another planet. Mars does not have plate tectonics, so in 2022, scientists at the University of Arizona concluded that these Marsquakes were not of tectonic origin, but were caused by the rise of a huge mantle plume 4,000 kilometers in diameter. It began to deform an area of Mars roughly equivalent to that of the continental United States. Interestingly, the previous work of the same team of scientists proved that where the magma chamber is currently rising, there was a volcanic explosive eruption between 53,000 and 12,000 years ago. This is the youngest known eruption on Mars. All this suggests that the dynamic processes in the Martian depths have not ceased to this day. If the planet, according to scientists, lost its magnetic field 3.5 billion years ago due to the destruction of the core, then why hasn't this magma hotspot solidified and crystallized over all those billions of years? What provokes its uplift in the depth? Where does the extra energy come from inside the dead Mars to lift the magma? After all, on a planet where the core dies, all internal processes stop, as there is no longer a source of internal heat. However, magmatic activity is now increasing on Mars, and in the coming years, we may even witness large-scale eruptions on the neighboring red planet. Unless, of course, similar events destroy us on our own planet before that. Time of life and death of Mars. You have just seen a lot of facts that contradict the officially accepted dates of the death of Mars. Think of unoxidized meteorites fallen in a dense atmosphere. Think of the thin layer of red soil on the rocks, the river valleys which have not been eroded, and the fragile corals on the seafloor. Academic science claims that Mars turned into a dead planet 3.54 billion years ago. However, all the evidence suggests that there was life, ocean, atmosphere, and magnetic field on Mars quite recently, no more than a few tens of millennia ago. If the planet had lost its dense atmosphere and ocean 3.5 billion years ago, the processes of wind and chemical erosion would have smoothed out and filled the relief of the rivers long ago. The wind, sand, and dust storms of Mars would have smoothed out any irregularities in the terrain. Yet, we see rivers, rifts, and signs of flooding as if giant channels formed by flowing water in the Mariner Valley area were made just yesterday. Let's figure out how is it possible that NASA scientists were so wrong in their understanding of the geological history of Mars. The age of rocks on other planets is determined by the number of meteorites that fell on them. The older the surface is, the more craters there are. If there are few craters, it means some processes in this area smoothed out the old craters. For example, lava was flowing or the ocean was splashing. Now, take a look at the topographic map of Mars. Once again, notice how few craters there are on the northern plains of Vastitas Formation compared to how many there are in the southern continent. How can this be explained? When there was an ocean on the northern plains, meteorites fell into water, leaving no craters. While on the continent, we see many craters of different kinds and ages. An attentive observer will note that not only are the northern plains almost devoid of impact craters, but so are the volcanic plateau of Tharsis and the Elysium volcanic region. This suggests that these eruptions occurred quite recently, in geological terms. And as mentioned earlier, it has been determined that volcanic eruptions occurred on Elysium only a few tens of thousands of years ago. How can we explain the fact that there are so many craters on the southern continent? It's interesting that if we remove the soil layers on the Earth's continent, we'll also see many craters throughout the Earth's geological history. In planetary science, there is a field of mathematical analysis called crater counting. It calculates the age of the rock surfaces based on statistical patterns. It is these calculations that led scientists to make erroneous dating of the death of Mars of 3.5 billion years. But why were scientists wrong in their calculations? Articles on Mars crater counting indicate the age of certain Martian surfaces as being 3.5, 4, or 2.5 billion years old. In other words, the accuracy of this method is now a billion years, give or take. So what kind of an accurate age estimation can we even talk about? Another important factor that introduced serious errors in crater statistics work was the appearance of a large number of craters on Mars due to its proximity to the asteroid belt. This belt formed as a result of the catastrophic destruction of the planet Phaeton due to the explosion of its core. Therefore, many fresh meteorite craters on Mars may have been caused by the fallen debris of Phaeton. Astrophysicist Rudolf Schildt, a Nobel Prize nominee, and a team of researchers believe that Mars lost its atmosphere and ocean not 3.5 billion years ago, but in the period between 100,000 and 10,000 years ago. Professor Alexander Mikhailovich Portnov asserts that the catastrophe on Mars occurred only a few tens of thousands of years ago. We hypothesize that Mars died 24,000 years ago during a cycle of most powerful cataclysms that affect the entire solar system every 12,000 years. Planetary scientists do not see that Mars died recently because they ignore information about the cycle of cataclysms and do not pay attention to the fact that climate change and the activation of the depths of all planets of the solar system occurs simultaneously. They only focus on the Martian surface and believe that the craters formed in the place of the former ocean are very ancient and have accumulated over 3.5 billion years. The shape of these craters indeed resembles very ancient, partially destroyed formations. We do not blame those scientists because in order to understand what happened on Mars, you need to know well what happens on our own planet during the 12,000-year cycle of catastrophes, which obviously lies beyond the competence of researchers studying other planets. During a cycle of catastrophes, when the impact from outer space delivers additional energy to the cores of the planets, their interiors begin to heat up, causing the cores to get displaced. Destabilization of the core in the planet causes anomalies in the magnetic field and the drift of the poles. The center of mass and the speed of rotation of the planet begin to change. Due to the energy entering the planet's interior and changes in the centrifugal force, magma begins to rise from the interior of the planet, just as it is currently happening on Earth, where magma is already breaking through the thinnest parts of the crust. The thinnest part is the oceanic crust, and now, due to the rise of magma, the ocean floor is heating up more than usual. The same thing is happening on Mars, as well as on other planets of the solar system and even on the Moon. Take a look at the flat, smooth surfaces of the ocean of storms in the Moon. That part of the Moon became so smooth probably because in the 12,000-year cycle, magma from the depths melted the crust in that area from within. The same process takes place on Mars. During the cycle of cataclysms, magma heats up the bottom of the former ocean and melts the ice below the surface, while the craters erode. This is why scientists believe that these are ancient craters that appeared billions of years ago. Numerous traces of crater healing, floods, and even traces of mega tsunamis in the recent past of Mars speak of endogenous heating of the planet's interior, the thawing of water-saturated soils, and the erosion of the former Martian ocean floor. For scientists unfamiliar with the information about 12,000-year cycle of cataclysms, these phenomena remain a mystery. Experts cannot imagine that their models and dating are wrong because they cannot answer a simple question: where did the atmosphere and ocean of Mars disappear if it died recently? Now we're going to tell you the most vital information for every Earthling. Are you ready to find out what really happened on Mars and what could happen on Earth in just 13 years? Hydraulic impact on Mars. Mars died suddenly. Recall, we do not see traces of the gradual retreat of the ocean. This means the ocean disappeared instantly. The dense oxygen atmosphere of Mars also disappeared under mysterious circumstances unexplained by NASA models. The oxidized red film over the entire surface of Mars could only have formed in conditions of the burning of the entire atmosphere. This sudden, unexpected cataclysm formed giant traces of water discharge. Only a single scenario of the death of living planets can bring together all these disparate facts into one frightening picture. Let's look at how this catastrophe happened on Mars. It all started just like it does every 12,000 years throughout the solar system. Extra energy from the outside began to enter the cores of the planets. The core of Mars also received this energy, and the interior of Mars began to heat up. The magma chamber beneath the Tharsis Plateau began to rise, just like what's happening now on Earth under the glaciers of Greenland and Antarctica. The humid, warm climate of Mars began to change. The global temperature on the planet rose by several degrees. The ocean began to warm up from the bottom. The number and severity of natural disasters began to increase on the planet. In the Northern Ocean, the number and strength of Martian hurricanes began to grow, destroying the coast. The current coastline of Mars has clearly observed areas of persistent hurricane landfall. Earthquakes began to increase in number and magnitude in the Tharsis and Elysium Plateau areas, just as they are beginning to increase even on dead Mars right now. Abnormally high tsunami waves appeared, traces of which have been discovered by scientists. Then, as a result of the weakening of the Martian magnetic field and the drift of the poles, anomalous auroras began to appear, just like it is happening on Mars and Earth right now. The instability in the planet's interior continued to grow. On two plateaus, Tharsis and Elysium, volcanoes exploded and catastrophic eruptions began, flooding everything around with liquid, unusually hot lava. This is evidenced by a huge area covered by lava flows. The atmosphere was filled with ash, and a sudden ice age began. Hurricane winds carried abrasive particles, bringing everything in their path to dust. Those were the same dust storms that now occur on Mars, only the winds were hundreds of times stronger. Earthquakes increased exponentially until the entire Mars began to shake with magnitude 10 Marsquakes. Magma plume under the Tharsis Plateau continued to uplift the area until at some point the magma met groundwater in the interior. At that point, the uplift burst with a catastrophic roar. This formed the Mariner Valley into which the cold waters of the Northern Ocean rushed. At that moment, in the central part of the Tharsis Plateau, where the labyrinth of Night Plateau is now located, there was a catastrophic rupture of the plume, and the cold water in the Mariner Valley instantly exploded, breaking through the atmosphere of Mars with a column of steam. This was a hydraulic impact with the force of millions of nuclear bombs. The shockwave from this explosion tangentially traveled inside the planet, expanding the magma in all directions. The impact caused the inner core to bounce back and stop, and the magnetic field of Mars disappeared in an instant. The moon of Mars most likely flew off into the sun. Water from the Mariner Valley rushed back into the ocean, forming catastrophic outflow channels. Mars exploded from eruptions, its atmosphere started burning and flared from electromagnetic discharges. Mars was burning, and our distant ancestors saw it. The blazing planet began to be covered with a red oxide film. At this very moment, literally in a couple of minutes, the torn atmosphere of Mars rolled up like a scroll, and since its integrity was violated, it broke off the blazing planet along with the ocean. The torn atmosphere and ocean of Mars instantly froze in the cold of outer space and turned into comets with a precisely defined momentum of movement in the solar system. Once every few decades, these comets return to their original home. Comets fly past Mars. So, it was due to the hydraulic impact that Mars lost its magnetic field, moon, atmosphere, ocean, and life in just a few minutes. This happened 24,000 years ago. Volcanoes continued to erupt on the planet for several more decades until they exhausted the energy impulse from the interior set by the cycle of cataclysms. The lava from the eruptions solidified after the magnetic field has disappeared, so the rocks did not retain their magnetization. The carbon dioxide released during these eruptions became the new atmosphere of Mars, sparse and cold. Water-saturated sediments froze in the ground. The only inhabitants of Mars that might have survived were molds and bacteria. Mars took on the appearance that we are used to seeing. Over the past 24,000 years, a number of meteorites have fallen on Mars, including ones from the asteroid belt at the location of the planet Phaeton. However, 12,000 years ago, during the previous cycle of cataclysms, the distorted interior of Mars received a new impulse of energy, and the volcanoes began to erupt again, while the floor of the former ocean heated up and melted. It was these processes that caused the craters on the northern plains to take on the appearance of ancient formations, causing scientists to push back the date of Mars's death to an uncertain 3.5 billion years. Why have thousands of scientists been misled and deceived about the true dates of Mars's death? Why has NASA been searching for life on Mars for 50 years and not finding any obvious facts in their own images? We don't believe that only fools work at NASA, but we are certain that they're not telling us the truth. And here is the answer to the question why they are doing this. Those who bought the opinions of scientists are well aware of the cataclysms that happened during the cycle, but they believe people do not need to know this because they hope that things on Earth will not be so bad and they will be able to wait it out in a bunker, but not this time. Nobody survived in a bunker on Mars. Here it is, Mars, dead and cold, evidence and the most vivid example of hydraulic impact, a rare phenomenon on living planets. Mars is a dead monument to a hydraulic impact, a terrible tragedy, and at the same time, this is our chance to understand the reality of the death of planets, the reality of seeing the same scenario on our planet. Now on Earth, we have also entered a cycle of cataclysmic events, similar to the one during which Mars died. The date of the repetition of the events of Mars and our planet on Earth is already known. It is the year 2036. The location of the hydraulic impact is identified. It is the Mariana Trench. Isn't it ironic that on Mars it happened in the valley called Mariner? Do you have enough facts now to understand that it's not a joke? If we continue to do nothing, in 2036 the ocean, atmosphere, and all life on our planet will disappear. But we and our children will be gone even sooner. We simply will not survive the increased power and number of cataclysms. And now it is up to each of you to decide whether these events will happen or not. People of Earth, I appeal to you. We deserve to live. We must not allow this scenario to happen again. Yes, Mars died, but its terrible example is a warning for us to never allow such a thing to happen on our planet. We can't prevent this catastrophe. The creative format of society opens up for humanity the access to a level of technologies that we cannot even imagine right now. Combining the potential of scientists will allow us to make a discovery about the impact that gives additional energy to the cores of the planets. This will take our science to a completely new level of development. We will be able to stop the energy coming to our core and even use this energy for our benefit. We will be able to control volcanic eruptions and prevent hydraulic impact in the Mariana Trench. But we can do that only together. We need each and every one of you to tell the truth about the threat of Earth's death, just as it happened on Mars. To tell all of humanity that there is a way out, and it is the creative society. We need each and every one of you. Let's not miss our chance to build the creative society. Let's choose life.